Hi, I'm David Buchanan, Applications Engineer for Analog Devices High-Speed A-to-D Converter Group. With me is Michael Sink, a software engineer in our group. Last time we discussed evaluating ADCs by using VisualAnalog along with an ADC evaluation board and the FPGA-based data capture card. Analog Devices evaluation boards and data capture solutions make ADC evaluation easy, but the setup is not always that trivial. Also, if an engineer is on the road or in an office setting, it may be impossible to have access to a lab setup. This is where ADC simulation is helpful.
With ADCM ADC, users can model ADCs under a variety of test conditions and perform the same types of analysis on the output. ADC models are sort of a virtual evaluation board in that you can preview converters without having an entire bench set up. Also, users can compare performance between ADC models and actual hardware to verify they are getting the expected performance. In this way, models are like a live data sheet for the ADC. Now, ADCs are usually specified by their rated minimum guaranteed sample rate and one or more key analog input frequencies. In most applications, the conditions used in the data sheet will be different. With the ADC models, users can specify the analog input frequency and amplitude along with the sample rate that matches their target application. Now, they can also be used from some third-party tools, but today we are only going to demonstrate their use with VisualAnalog.
There are many benefits of using modeling design tools. First, converter models help simplify the part selection and validation process. Users can speed up product selection by quickly checking ADC specifications and analyzing the output of the model. System simulations are already done today with ideal converter models, but why not refine this to reflect real-world behavior? By incorporating actual behavior of the real ADC, the user can gain confidence in their design.
ADCM ADC incorporates many parameters such as noise, harmonic distortion, SFDR, SNR, jitter, DNL, INL, and latency.
ADC models are not included with VisualAnalog. However, they can be easily acquired at analog.com/ADCMADC. On this website, there's a list with all of the available models.
To run these models with VisualAnalog, it is recommended to extract them to the Models/ADC subdirectory in the VisualAnalog install path. By default, this is the location. Now, once you have downloaded the ADC model file of interest, it's easy to run the model using VisualAnalog. You can simply start the software and select the appropriate device in the startup form. Today we're going to demonstrate this using the behavioral model for the AD9246, a 14-bit 125 megasample per second ADC. Now for this example, we'll take an FFT for the ADC output data. Notice that I select ADCM ADC FFT. Now, when I click the Run button, you will see the FFT results on the graph as well as on the left-hand side. Notice if I click the Continuous Run button, you'll see the graph update continuously.
These graphs illustrate the accuracy of the ADC model with respect to actual performance. The two plots on the left show the FFT of the real data on top and the FFT of the model data on the bottom. The two plots on the right are the worst-case spurious-free dynamic range versus analog input level. As you can see, these plots match very nicely.
Oftentimes, a user may want to perform a different test with an ADC model, such as a two-tone test. So here with my startup menu, I can select two-tone, and then you see the results of that. Also, sometimes a user may want to see the ADC response to other user-defined inputs. Now, VisualAnalog allows this by providing a pattern loader component. Here's an example canvas that loads an input file from disk and sends the data to the ADC model. This specific input file happens to contain a WCDMA channel. Now, when I run this canvas, you can see how the ADC performs with this input signal.
Setting up these input conditions in the lab would certainly not be easy. This is a great example of where using ADCM ADC can save time in the design process, particularly early stages of the design when you are just selecting components. Thank you for joining us. For more information, please visit analog.com/VisualAnalog.